Okay, so today we're going to look at using the analog for modulation with our modular synthesizer. So the analog for each track has two dedicated envelopes and two dedicated LFOs, each of which have two separate destinations that we can assign, and each of which is also cross-modulatable, meaning I think envelope 2 can modulate LFO 1 and LFO 2 can modulate envelope 1. Which means we can get some quite complex, interesting modulation going. We can also use parameter locking, which we'll get into later. But for now, what we're going to do first is we're going to use the analog 4 to make a very simple envelope to control the VCA circuit in ripples on my modular synthesizer. Okay, so what we're going to do to set up this patch is we're going to hold function and CVA, and we're going to assign that to pitch like we did last time, so that we can control the pitch of our oscillator, which in this instance is braids. So we're going to click out of that, and we're going to take the yellow cable, which is my CVA, and plug that into the pitch input of braids. Then you're going to take the audio out of braids and plug that into the audio in of ripples, and then we're going to run the VCA low pass output of ripples into my spring ray, which is going out straight into the analog 4. Okay, and then we're going to press function and CVB. Now CVB we're going to want to be our envelope that's going to control the VCA on ripples. So to do that, we're going to want to set this one to something called value or linear value. Okay, now this value we can set the minimum to minus 10 volts and the maximum is at 10 plus 10 volts. Which means we can actually, in the settings here, we can achieve offsets and attenuation, which can be really handy, which I'll show you in a patch later on. But for now, we want this to control the VCA, so we need the VCA to completely close so that there's no sound. And so we're going to have the minimum be 0, and our maximum is going to be 8 volts. Okay, so the value, you can see here, is actually already set to 0, which is also very important, because we want our envelope to close. We need the value to be all the way down by default, so that we don't get any sounds. Now over at the modular, this is CVB from the analog 4. This is going to go into the control for the VCA on ripples, and plug that in there. Now we've got pitch and we've got CV going in here to control the VCA. Now we need to set it up on the analog 4 so that we have an envelope controlling this CV. So the way we do that is we click envelope. And there are two pages. Red LED is envelope 1, green is envelope 2, same with the LFO page. Also says up here. So what we're going to do now is we're going to choose the destination of our envelope. And we want the envelope to control the value of CVB. So basically you can control the voltage range that we set earlier in the settings. So by turning the dial, at the moment it's set to CVA, which is our pitch, so we want to change it to CVB. You can see we've got coarse tune, fine tune, value, source track, which is quite interesting, bend depth, note slide time, and then we got the same for all of the other CVs. But what we're going to set this to is CVB value, and you have to click to confirm. It says here confirmed. Okay, it's very important. That's so that if you accidentally hit the dial, you don't lose your settings, because only for the destination. The other ones, you don't need to click, but just for the destination, you need to click down on the encoder to actually input that setting. Okay, so now the destination of our envelope, which is a standard ADSR. There are 11 shapes, all different, logarithmic, exponential, and so on. So our ADSR is controlling value once we turn the depth all the way up. We also have this setting here, which is length. At the minute it's set to off, but if I set this will control it like a triggered ADSR, so that we don't have to worry about note length within the sequencer, which can be quite handy. We can also use the LFO to control parameters on the envelope, and we can also use the envelope to control parameters on the LFO with some quite interesting results. But first of all, we just want this to create a simple envelope so we can use with braids. So our depth's all the way up, our CV value is all the way down. When we play a note, we should get a sound. Cool. So let's put some notes on the... we've already got some notes in there. Let's press play on the sequencer. And while we're we're doing that, we'll just play around with some of the settings. Let's turn the sustain down so you can hear how fast the decay goes. It goes really, really short. Literally down to a tiny click. There you go, just a click. We also set the attack. The attack can go quite long. And there you go. Okay, what we're going to do now is we're going to use the LFO to control the wavetable, the timbre on our braids, for the same patch that we just did with using the envelope. So how we're going to do that is we're going to use CVC this time. Let's go function, CVC. Again, we're going to set this one to value. We're going to leave it at 0 and 5 volts. And then what we're going to do is, this is my CVC. I'm going to plug that into the timbre input on braids and turn the attenuator up. Okay, now if I go to LFO, clear the page from my last setting, I'm going to set the destination to CVC value, click to confirm, turn the depth up. Now when we play out the same sequence we were playing a moment ago, we should get some modulation on the wavetable. Now what's quite cool with the Analog 4 is our modulation LFO, we can actually set it to reset a trigger, or we can set it to hold, which means it will hold its value whenever a note is triggered, which is very cool if we use the random. That means now we'll be getting a random value every time a note is triggered. Pretty much like a standard sample and hold, I guess. I can increase the depth a bit. Okay, what we're going to do now is use the Analog 4's sample and hold LFO to create a sort of generative patch using a quantizer and an oscillator in the modular. Okay, so the way we're going to do that is we're going to again go with a function, CVA, and use value. Okay. Now what we're going to do, we're going to have a LFO control the pitch of our oscillator through a quantizer. But that means we're not going to want notes that are really low. So if we had the minimum value set to 0, we're going to be getting really low bass notes. What we can do with the Analog 4 is we can offset that, and if we set the range from 3 volts to 5 volts in pitch, volt per octave standard, that's 2 octaves that we've got there. So we can confine the pitch of the LFO using the Analog 4, which is very handy. Okay, so we're going to exit out of that. CVA is the yellow cable, which is going to be our random LFO. We're going to go that into the input of Disting's quantize in, which I believe is X. Okay. Now what we're going to do with that is we're going to take A, which is the quantized out, and run that into the pitch in on the Hertz donut. I'm going to take the output of the Hertz donut and run that into the in on Optimix. I'm going to take the out of Optimix, run that into my spring ray, which is going all the way into the A4. Here we got a sound. Let's close that. And then also the Disting has a nice little feature where every time it creates a new pitch with the quantizer, we get a gate from B. So we're going to use the gate to trigger function and use the end of rise on function to strike the Optimix, so that whenever we get a new value, if I change the value here, we should get a new note. And now to make this quite interesting, what we're going to do is go to LFO, and we're going to assign a random sample and hold LFO. We're going to assign that to CVA, to the value of CVA. Click confirm. Put a trigger on there. So now our random LFO is creating notes via the quantizer. But what we can do that's quite interesting on the analog 4 is the analog 4 lets us use something called hold, which is much like the freeze on the function, or sorry, the hang on the function, or the freeze on tides. And what we can do here, this will hold the value for each trigger. So we can actually choose a rhythm that's not actually the same as the clock. So if we go into the sequencer and we choose hold, we get a new note every time it triggers. And these don't have to be evenly spaced. There you go, using the analog 4 to make generative music, kind of.